To illustrate probability, in this video I pull up a simulation from shortor.org. They actually have a variety of simulators, and what we're looking at here is the dice sum simulation. So what this simulation does is it simulates rolling two dice that are six-sided, balanced, so each side is equally likely to turn up. The equally likely part, that we're going to interpret that later, but what it does is whatever two sides come up, those are the sides that are going to be added together. So if you're looking at, for instance, 3 and 4, then those would added together would be 7, and then that gets tallied. So every time that you roll once, that gets added, whatever turns up will get added to the tally. Now we use simulations typically because to do this, to carry out these experiments repeatedly would be very time consuming, and the technology has advanced far enough that we can actually integrate quite a bit of actual randomness. So the first roll there has landed on 7, and then every time we roll again, another tally gets added. So the number total of rolls that we have here so far are 2, but each time we get a different outcome at random. Now, doing it once or twice isn't going to give us a very good picture of what we're doing, but if we do it several times, then we can start to make predictions about what random outcomes are more likely than others. So far we're only rolling one at a time, but we're doing several. And for the most part, they appear to be clustering in the middle region from like 4 to 8, 5 to 8 roughly. And so you can continue to do that as much as you want. This simulator in particular, you can actually do multiple rolls, simulate multiple rolls at once. So it actually can go even faster. That's what we're going to do here in a second, see? So now we've started simulating 10 at a time, and each time we're adding more and more tallies. And so we are starting a more accurate picture of the distribution of outcomes is starting to show up. So we appear to have reached our maximum number of rolls that we can simulate, which is in the hundreds. And so we can see that there are much more tallies in the middle number, so you're much more likely to roll 2 dice and get something between 4 and 8, for instance, clustered at 7, than you are to get something on the extremes, on the outsides, like 2 or 12. So if you've ever played Monopoly, this applies directly in that what we're talking about is when you want to advance, move further ahead than others, you want to roll a 12, but that's actually not a very likely outcome. What's more likely than not is that you'll get something like a 6 or a 7 or an 8. And then sometimes, yeah, you do have the misfortune of rolling something much lower. So this ties into what we'll cover later in this unit, but every time we roll now is an independent random outcome, and we can use the distribution of outcomes here to predict what the next outcome is going to be. Right? So we're more likely to see something like a 7 or an 8 than a 12 or a 2. And that right there is an illustration of what probability is telling us quantitatively. This specifically is what we call experimental or frequentist probability. And in the next video, we'll formalize talking about the different interpretations of probability.